In this question, we are asked to find the center of mass of a toy which is made by joining a cone and a hemisphere. If we draw its shape, it will be something like this: a hemisphere with a cone on top of it. And this point is the vertex of the cone. And we are asked to find the center of mass of the toy from the vertex. So the formula for calculating the the center of mass of a cone from its vertex is 3 upon 4 into the vertical height of the cone. And the formula for calculating the center of mass of the hemisphere from its base, which is this this horizontal line, is 3 upon 8 into radius of the hemisphere. So we'll draw a table to calculate the center of mass of the combined object from the vertex of the cone. We'll have two columns in this table, one for volume and one for center of mass, which is abbreviated to COM from vertex. And then we'll have three rows, one for the cone, one for the hemisphere, and one for the combined shape. Okay, so now the formula for calculating the volume of the cone is 1 upon 3 into pi r square into height, which is 3r. So we'll write 1 upon 3 pi, radius is r and height is 3r. So this comes out to pi r cube. And the formula for calculating the volume of hemisphere is 2 upon 3 pi r cube. And since the radius is r, so it will simply be 2 upon 3 pi r cube. And the volume of the combined shape will simply be 2 upon 3 pi r cube plus pi r cube, which will come out to 5 upon 3 pi r cube. Okay, so now we have to find the center of mass of the cone from vertex. So it will simply be 3 upon 4 into vertical height. Vertical height is 3r. So it is 9 upon 4 r. Okay, and the center of mass of the hemisphere from vertex. Now you have to keep in mind that we have to add the vertical height of the cone into the center of mass of the hemisphere from its base, because we are asked to find the center of mass from the vertex, which is this point. So we'll actually have to use this whole length. So the center of mass of the hemisphere from the vertex of the cone will be 3 upon 8r plus the vertical height of the cone, which is 3r. So it will be 3r plus 3 upon 8r. And then we'll use x bar to represent the center of mass of the combined shape. And we'll put this in an equation. 5 upon 3 pi r cube into x bar is equal to the volume of cone, pi r cube into 9 upon 4 r plus the volume of hemisphere, 2 upon 3 pi r cube into the center of mass of the hemisphere from the vertex, which is 27 upon 8r. 3r plus 3 upon 8r is 27 upon 8r. Okay, so now if you simplify this equation, we can cut pi r cube on both sides, and we'll get 5 upon 3 x bar is equal to 9 upon 4 r plus 9 upon 4 r, and 9 upon 4 r plus 9 upon 4 r is simply 9 upon 2r. So we'll get 5 upon 3 x bar is equal to 9 upon 2r, and we'll have the answer x bar is equal to 27 upon 10r. We were asked to show that the center of mass of the toy is 27r upon 10 from the vertex of the cone, and we have shown it here.